Okay, there's the link to Community Update 189. We have two demos today, one by Tomislav and one by David Asamonye. So I'll just go through my part and then Tomislav will start. Okay, you should be seeing my screen now. There has not been any change on the networks. The states of the networks remains the same. So I'll just jump right into the development effort where we are. So we're getting ever closer to getting the HF2 release ready for testing. And NutZipper is able to reconcile, NutZipper is working on leaderless block merge, and he was able to reconcile his changes for leaderless state merge. That's based on a fringe or boundary of previous last finalized states. He's able to reconcile that with the code base and is able to compile R node to run locally. He's testing this for any logical issues, and he found some. I think in particular, he's trying to make some changes to finalization and Casper so that finalization can move forward in all cases. So that's where he is on his piece. Tomislav is going to demo his progress today on the merging of REV balances. I think Tomislav has a little bit more work to do to complete the REV vault merging, and he'll speak to that when he does his demo. The other, of course, as we, to get to the HF2 release, we need to get both these pieces reconciled with the existing code base, and there may be some tests that need to be refactored and then run them and then troubleshoot any identified issues. That's the effort left in the leaderless block merge, meaning or I should say the hard fork 2 overall. It's leaderless block merge as well as the REV vaults merging. We have been trying to troubleshoot one issue when we ran the performance tests. That is that we are seeing the linear scaling up to some nodes, like 25 nodes or something like that, but then we see taper after that. And we're trying to run it last week or this week rather. What we did was we tried to see if the tuple space is, the increase in the tuple space as we go to more nodes was part of the reason. But we seem to, at least as of now, we seem to have eliminated eliminated that as a potential source of that. So what the team did was they went from 1 node to 100 nodes. And of course, the tuple space increases as they do that. And then they came back from 100 and down to 1. But they did not see that being an issue, the tuple space. And we had previously ruled out disk IO or memory or CPU or any of those things being the gating factors. So current suspect is JVM or related issues like heap and things like that. We have not seen anything in the code itself that is slowing things down or that should slow things down. So what Bill is doing now is he's further simplifying the test scenario to just run produces and consumes without any refund or pre-charge, and then observe the behavior basically to see if we can learn something by going from bottom up and saying, okay, what can we run the simplest of things, or does that also get gated by the environment in some way? And then that might give us some clues as to whether the machinery is the one that's getting in the way or whether it is something else. So that's kind of what the debugging step or stage we are in with that. Dennis is getting his PR ready for, he may already have it by now, for Radix tree implementational history. Initially, this is going to be merged onto Tomislav's branch. In his initial test results for performance, he has demonstrated about a 2x improvement on inserts, but he will be doing more testing for reads and deletes, and then update the PR with that so that all that data is available performance improvement data is available to the public. Now, in terms of actually getting the full impact of what he has done on the entire code base, we'll have to take it through the other pieces that need to be done and include that in the code base. So there's some work to be done there, but at least we're moving in the right direction in terms of the performance improvement there. So those are my updates from a development effort standpoint. The only other thing I did in the report was I clarified here that the external validator process, when we get to it, would initially have the trusted community validators, we're also calling it friends and family, on the test net initially, and then on the main net. And then potentially with the extended ecosystem, like parties that we're already working with, like exchanges or something like that, if they're willing to do that. And then eventually the external validators in the wild. So that's, I clarified those steps a little bit more in this compared to last week, if you look at the version from last week. But there is really not any serious change in plan or anything over there in terms of how we're going about that. That, I think, is my update. Before I turn it over to Tomislav, are there any questions, comments on this? All right, over to you, Tomislav.
Okay. So basically, this feature is pretty simple from the user perspective, but we need to do some deeper changes in rholang execution. So basically, what we want to do is be able to merge REV vaults, although they are like used, they are using the same channel. So basically, if we have this kind of situation, and this is exactly what I want to show in my demo. So if we have 3 users. For example, Alice wants to send some revs to Bob and Charlie. And when we have the block merge, we can have situation where we are starting from some common block, and Alice can send 2 deploys to 2 different validators at the same time. So this means that this block 1 will be created on one validator, but also a block with the same number will be created in another validator. So this means that if Alice is sending, creating deploy or sending 10 revs in one block to Bob and 15 revs to Charlie in another block, Alice will be, from the perspective of normal blockchain, this will be like double spend, right? And usually one block will be discarded. In our current implementation of block merge, so this is why we extended the scope of block merge, so that we can have even multiple blocks from the same validator, which we could not be able to do with leaderful. So this is why this feature is so important. So from the perspective of normal blockchain, one block would be discarded, or in our implementation, current implementation of block merge, we would discard one of the deploys that Alice created. So what I'm doing in changes to the REV vault is basically detect channel on which Alice or REV vault is storing the balance, so that when we are creating the merging block, we can decide is this competing transactions, can we merge the balances. So what we want to see at the end is basically transactions to Bob and Charlie succeeded, and a balance on Alice's vault to reflect this change, to be correctly calculated. So this is what I want to show. I will start 2 nodes. This is the first validator, this is the second validator, and I have the testing page to create these transfers. So we see here 2 validators are bonded and they're starting. I have some wallets defined that I'm using for testing, and one of the wallets is Alice wallets. So okay, now we have it started. First, I want to check the balance. So we have a starting position. So we have 100 revs for Alice, and Bob and Charlie should be 0. Okay, so now first I want to send 10 revs to Bob, and I'm sending this. I'm choosing the first validator here. So we will see in the first terminal. This is the deploy, but it's not proposed. This is important. I modified the page a little so that this transfer does not create the propose in the local host, because we want to have these 2 branches that are created in parallel, so that these validators will not build block one on top of the other. Okay, so the second one is for Charlie, and this is the 15 revs. Okay, so now I want to propose simultaneously. So I'm just using 2 requests for both validators at the same time, and we will see that they are now proposing. After they create this block here, to be able to see these transactions, we want to have this block finalized. So I will create some additional blocks on top of it, so that this block is finalized and we can see the balance. And this is the part on which Anton is working, so that this finalization reflects our capability to merge blocks, because we will be able to finalize based on state, not based on blocks, which will enable us to make finalization faster. Okay, let's create another. Okay, now I want to check Bob. Bob has 10 revs. Charlie have 15, and Alice should have 75 minus cost of these 2 transfers. So this is basically the demo that I want to show. What is left? How this works? I want to say just a few words. We are using a non-negative number contract to track balance in REV contract. And we will have some special channel, which will be like a tag, or we can say some kind of label for special type that we will mark this channel. And then we can when we are executing the code, we can memorize these channels, memorize the difference created in each deploy, so that in merging, we will load this data and use it for like additional data for merging. And so what is left to do? I have a working version to merging, which was the biggest part, but now I need additional code to reject. For example, if Alice spent more than it have on Revolt. So this code is missing to reject deploy based on the balance after the merging. And this is and also one thing. Now I'm using a fixed channel to tag this fixed channel to tag this channel. So we need to use another channel which will be unforgeable, so that no one else can mess up with the Revolt. And this is basically it, what I want to show. If there is some question, please let me know.
So just a point about nomenclature. Typically, double spend refers to the case that you're still working on, which is that Alice overspends. She spends more than what she's got in her account. not the case that you have here is not really a double spend case. It's just that there are simultaneous transactions against Alice's.
Yes.
Yeah. Yeah. But that's a brilliant demo.
Yeah, it's a very nice demo. So Tomislav, on the double spend, when we do that, are we going to basically, I guess, reject the whole deploy? Because you are doing these, even though they are parallel, you're doing them in a single deploy, and you would reject all of them.
Yeah, yes, deploy is like unit of rejection that we have.
So all the transfers would be rejected in that scenario.
Yeah.
Okay. Does anybody have any questions for Tomislav?
Thank you very much, Tomislav. Great work.
Thanks.
David, are you ready for your demo?
Yeah.
Okay.
Okay. Hello, everyone. Okay. Basically, this is the latest version of the proof of concept of the NFT Eve Arnold project. So these are the 4 main functionalities that can be carried out on the in the project. So the very first thing, which I believe we've seen before, but I would just run through the entire process, is publish. So okay, so we can upload an NFT. So let's upload the test NFT and enter price, let's say 250 REV. Then drop an image, and we can request a name for the attester. So presently the attester we have is Magnum. So this the name fetches the registry URI that is attached to this particular attester. So once we hit the uploads, okay, so the entire transaction takes about 30 seconds. So in the future, for user experience purposes, there's going to be like a loading bar that shows the exact state, the exact progress. So to make it a little bit better to track or monitor. Okay, so now that that is done, okay, so a test. Okay, we can see the photo and then the signature of the publisher, and we can attest this. Attestation also takes a quite similar time that publish takes. That is around 30 seconds. Okay, so the next thing is for us to make a purchase. With that, we go into the marketplace. We can see NFT with the price, so 250 REV. But before we make the purchase, I would like to show a balance. So we can see we have about 1 million REV. That's 999,999. So that's about approximately 1 million REV. So we should expect 250, including the flow or gas fees to be deducted from the balance. So once we buy, the purchase also takes 30 minutes. So what's happening now is that the NFT is being transferred from the marketplace or the publisher to the buyer. Okay. Then if we check owned NFTs, that is my personal wallet, we should see the NFT, and that is the NFT here. So owned, test owned. And then if we check balance, we should see that's about 250 REV, including the fee, the gas fee has been deducted from REV balance. So that basically is the progress of state of affairs for the NFT PoC project.
It looks so nice. It's it's coming along nicely. One tiny nit. It's not really the Arnold. I know Arnold sounds like if you put your fingers in yours, it sounds like Arnode, but it's not really Arnold NFT, right? It's really RChain NFT. So maybe
yeah. So it's like the whole stuff is going to be changed. So a lot of the stuff has not been worked out yet. So
yeah. Just teasing you a little bit.
okay.
Awesome. Thank you very much. Any other questions for David?
Yep, that's great. Just to reflect on that. So I'm not part of the team who builds this, but just to say that this uses the same rholang code that Dappy uses. So it means that it's all the same interface. It's RChain token. And like if you purchase this NFT, it's the same thing as purchasing a name in the Dappy name system, and it's the same interface you use to build a personal page on Dappy. So that's the good point is that we are reaching a state where some different projects can use the same standards and work with.
Yeah, exactly. So Raphael, it's the projects for everyone. The project was built on RChain token and RFM. So yeah, so
very good.
That's basically what Raphael was.
Yep, just to emphasize the fact that we are not each developing our own thing, but we are relying on the same code bases on the rholang side, of course.
Yeah. So are we? I mean, this is really good news. One question: I know that Dan Connoly still had some questions about RChain token and the NFT framework. Have we been able to reconcile with his questions, or are those still outstanding?
No, it's still, I would say, to be discussed.
Okay.
And yep, that's the discussions. I did not have discussion with him for like a few weeks, but maybe we'll set up a session to talk about all this.
I think that would be useful. I just want to make sure that his perspective is well reflected in our considerations, because Dan has, he's a smart guy.
Yep.
All right. Any other questions for?
Yes, I do have a question for David. So David, what was the format for the photo? I missed that part.
Okay, so it's gonna be a PNG JPEG image.
Okay, thank you.
Very good. All right. So we had a very good board meeting. Let's see, we did in fact approve the minutes. So I think they've already been published, but the minutes were approved. Let's see, there was we're in the process of putting some parameters around another contractual negotiation that the co-op is engaged in, and I can give you more details about that in the Friday session. I can't say much, but I can say that for those of you who are fans of the healthcare Passport Initiative, we have some good news. So I'll talk more about that on Friday. Darryl, are you ready for the week in review?
Yes, I am. Thanks, Greg. So here's a week in review for September 9th to today, September 15th. Last Thursday at the governance committee meeting, the conversation mainly revolved around a point brought up by Rao, suggesting we work towards project managing the efforts to onboard developers and education, etc., towards making it as smooth process as possible. And Jim spoke of the object capabilities angle and the work he's doing there. On Friday in the Climate and Coordination RCast, we discussed a warning from 230 medical journals that names climate as the greatest threat to human health, as well as Generation Z's, or Z, I should say, Generation Z's mobilization in the workforce toward careers in climate solutions. We also discussed fossil fuel subsidies and an election in Canada. On Monday's Casper Standup, they're building on last week's Casper Standup, where they discussed the range of application of the rho calculus to chemistry and biology and psychology. They visited a variant of the rho calculus called the space calculus. The aim of the space calculus is to provide a notion of dynamical systems that are located in space and time. Of special interest is that space and time are emergent as opposed to prefabricated. Let's see here. Yesterday in the communications working group, let's see here. I don't actually have this written in here yet. We discussed the update on the NFT mostly. Also yesterday in the DApp developer work study, Jim and Jorge had a rholang education session. And this morning in the members hangout, discussed Jim attending Bill's wedding, Jim's chronic back pain. We also discussed the new Telegram channel, and Theo and Raphael were talking about the recent developments in the proof of concept. And that's it.
Thank you, Darryl. Any questions for Darryl? Okay. I will elaborate a little bit regarding the space calculus. The Casper talk was in preparation for a meeting with Bob Coecke and his associate, who are at Cambridge Quantum Computing. So Bob and his colleagues have developed a theory of mobile agents in space from Bob's work, which basically reformulates quantum mechanics. And so we wanted to compare notes in terms of the rho-based approach versus Bob's approach. It was a very good meeting. And one of the things that I came away with, especially after looking at their results, was that this using Bob's framework for a quantum consensus feels even closer to hand. So Bob made some very specific comments that made it easier for me to line up what they're doing with the way we think about Casper. And this is, it's a long-term line of investigation, but I think it has significant fruit. And this is, sort of what I've been talking about since 2018, that ultimately we want to replace the consensus algorithm with a quantum-based algorithm. And I want to point out that Cambridge Quantum Computing is well funded and very serious about developing high-end quantum compute capabilities in terms, hardware-based quantum compute capabilities. So of the players to be talking to about a quantum consensus, they're about the best people you could be talking to. So that's worth certainly worth the time and effort that we put into it. Any questions about that? All right. Anything else anyone wants to talk about, chat about, or cover? Any burning issues?
I just have a question about the quantum compute explorations that you're doing. Do you know of any other blockchain platform that is pursuing this kind of stuff?
Nope. The only time I've ever heard quantum mentioned with blockchain is with respect to being quantum secure, so robust against quantum compute. So, you know, to me, that's a no-brainer. You make sure that your security is modular and you can plug in the right quantum resistance, key mechanisms. So our architecture is modular in this regard. So that's software engineering 101. But this idea of using quantum mechanics to do the consensus, while I mean the academic world has been, I know that Prakash Panangadan was thinking about this in 2008 timeframe. But I looked at his paper and yeah, I mean, I feel like there's another way to do it, and that's sort of what Bob and I've been talking about.
So if like a quantum computer came out tomorrow, would that neutralize the Bitcoin protocol? Like, would Bitcoin be in trouble?
It depends on how their architecture. I haven't looked at their architecture. It's not necessarily. They could have quantum resistant security. I mean, the reality is that all of those protocols are actually much less secure than people imagine that they are. You know, so for example, I know that, you know, some folks that we know, some engineers that we know, were approached by an individual who had lost his private key and had, you know, tens of millions of dollars of assets under that address, and asked them if they could crack it. And so they thought about the problem and were able to whittle down the search space considerably, and until it was a brute force problem that they could realize on decent hardware. And then they ran the brute force and cracked it, and got a paper in DEF CON last year about exactly that. So, and so if you think about that, and not even just the quantum hardware, but just the more recent advances in terms of parallel hardware, whether you're talking about the GSI chip, or you're talking about the chips coming out of Tesla and their Dojo architecture, or the photonic stuff, all of that stuff is at a point where it could make, you know, taking these whittled down search spaces, which are still large and costly to search, but not, you know, not impossible, and they could bring them down to minutes. So those networks are not very secure. But if you've done your architecture in a modular fashion, then you can replace less secure cryptography with more secure cryptography.
So in theory, Bitcoin could do that?
In theory, again, I haven't looked at their software architecture. If their software architecture is bad, then, you know, it might be a mini month or couple of year-long effort to get it all correct. But if their software architecture is good, then it should be, you know, a week's worth of effort to switch it out. But you know, that's not where I'm interested in terms of quantum mechanics. I'm interested in a consensus algorithm that takes no time. You know, or it takes the time of a measurement, or a suite of parallel measurements, right? So you make some observations of some entangled states, and that's the taking of those measurements is all that's required to achieve consensus.
Wow.
Yeah, that would mean that the slow bit would be the rholang execution, right? Because if you think about it, for the kinds of data applications that we're talking about, already just the data uploads, when you're talking about bulk uploads of, millions of photographs or millions of healthcare records or that sort of thing, then the consensus overhead is tiny by comparison to getting to the upload times, right? It's only in payment transfers where you have the consensus overhead, dominating against, because the data transfer in a payment is just a single number, right? But in the data transfer in a significant data application is, potentially a photograph or an audio or multiple photographs, or in the case of healthcare records, some x-rays and some interviews and some physician's notes and blah, 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 right? That could all be a part of a healthcare bundle. In which case the data upload time is going to dominate the consensus negotiation amongst all the nodes that are going to replicate the data. And again, if we do it right, I know that Node is not organized like this right now, but what needs to happen in the not too distant future is we make sure that the consensus is around the hash of the data, and the sending of the data across to the nodes is done in a backplane, right? It's a separate thing, right? And you can guarantee that you've got the right data with the usual tricks, checksums and those sorts of things. So you just do the consensus over a hash, and then the data is subsequently transported or distributed amongst the nodes, and then Bob's your uncle, so to speak. Does that make sense?
Yeah, I think so. It's pretty fascinating.
It's a lot of fun. And then if we do the quantum stuff, then there are several advantages. One of which is that there's like essentially zero runtime overhead for the consensus. Right, it's all how fast you can upload the data, and then it's up to us to optimize the rholang execution, which we're working on every day.
Cool.
Yeah. All right. Any other questions or comments? Great. Thank you all. Please stay safe, stay cool, and we'll see you on the other side.